criticism. Where's
What?
error analysis?
Error analysis of what?
You can do error analysis with a virtual lab because then you basically don't have error.
What? Are you talking to me?
Yeah, I was talking. You were talking about virtual labs. I'm like.
Oh, okay, I see.
Virtual lab. It takes away the whole point of doing the lab because well, I think the point is to prepare for doing more physics lab experiments in actual research, but that's just my bias speaking.
Oh, okay, I see. Yeah, it depends on the purpose of the lab, as you said, because if the purpose of the lab is to introduce the concept that is already known, yes, that a virtual lab can be useful, especially when you are talking about people who do not necessarily have access to a school, like, in a rural part of the United States, people have to drive, 2 hours just to go anywhere. So children in those particular places are very hard. It's difficult for those children to get education like the way we do in a more densely populated area.
Yeah, plus third world countries probably don't use.
Oh, yeah. All right, so let's go back to this class. Are there any questions about the homework assignment? Oops, wrong class. No questions? Now I did finish it, so let me kind of show you the solution, and I will post it onto Moodle just in case someone wants to download it and use it as a basis for your actual homework assignment. And I said it's okay, so don't worry about that part. So app inventor. This one I need to sign into another account for sure because I did it here. Okay, so here's the Get Them All, the original Get Them All homework assignment. Yes, I did use a very small, sphere or circle sprite, but it works. Okay, it's fine. And the blocks, represent the actual logic. So what I did end up doing was not to use the color to detect whether the ball sprite is on top of a circle or not. I just use the distance between the center of the sprite and the circles to detect whether I should be on the circle that is still on the canvas or not. Yep. Mm-hmm.
What do you mean by the distance? You mean from the edge?
To the center. So from the center of the ball sprite to the center of the circle. So I measure that distance. If that distance is less than or equal to the radius of the circle, then I know that I am inside that circle. And I use a fourth value in a circle representation in the list to say that, okay, have I been here already? So if I have not been there already and I'm inside that circle, then I say, okay, I just hit a circle, and then I mark that circle as hit at that point, so I won't double count it in the future. Okay. So I'll show you the code. It's actually, so everything starts from drag, okay? We are not even talking about the initialization part because that was done last time. Okay, so I changed erase circle a little bit to say check erase circle. In other words, it is not just a procedure to call to erase a circle. It would actually come back and say, did I erase a circle? Okay, and this part is the current point, which probably is incorrect because this is the x and y of the upper left edge of the ball sprite itself, not the center. So if I want to get to the center, then I need to do some calculations here. I might as well do the correction since I'm already here. So the center of the coordinate of the center of a ball sprite is technically this number minus plus the radius, okay, because this is the current x of the upper left edge of the ball sprite. So the center is this number plus the radius of the ball sprite. So technically speaking, if I need to be correct, I need to do this plus the radius of the ball sprite. So here's the ball, and then the radius is a property. So we have to do something like this to be exact, and I should do the same thing with the y as well. So I'll fix it. So when I upload this will actually be correct. Okay, there we go. So what this is it's calling this particular procedure called check erase circle, and it's passing along the x and the y of the center of the ball sprite, not the upper left edge of the ball sprite. But because I pick a ball that is so small, it doesn't really make that much of a difference. But when your ball is like kind of big, then it does make a difference, okay, where the center is. So this will basically pass the center of the ball sprite to the procedure. So now we need to track down the procedure and say, okay, but what is it doing, okay? And also note how the return value of check erase circle is used as a Boolean value, because what it is being used for is inside the conditional statement. If the return value of check erase circle is true, and only in that case, I will perform the rest of the operation. The rest of the operation is basically saying, okay, we did hit just a circle that is painted, and it's time to do some calculations. For instance, we want to say that, okay, we have just hit another circle, so the number of remaining circles is going to be one less than what it used to be. And then when that number gets to 0, then I also know it is time to end the game, okay, which involves turning off the timer and also changing the text of the button. Do we want to start the new game? Okay. So the main logic is actually inside here, okay, inside check erase circle. This is a particular instance of top-down design, okay, and it also shows why top-down design is useful, okay. Can someone remind me what is quote-unquote top-down design? This is something that should be explained in cisp362, okay, and we are well over 1/2 of a semester, so even people who are taking 300 at this time should have encountered that concept already. So what is top-down design? We talked about it in this class as well. Yep.
Top-down design, when you take the highest level of what you're doing, you work down, so you don't have the smaller pieces
Right.
until the end.
Yep.
You work from the highest down.
When pushed to a very unhealthy level, it's called procrastination. I'll do it later. I know I have to do this, but I'll do it later. Okay, this is the favorite things that my kids tell me. Luke, have you practiced piano? I'll do it later. Have you double check, have you checked your planner for the day and do all the homework? I'll do it later. Okay? Same thing here, okay? Same thing here. I need a mechanism to see if the center of the ball sprite is in the middle of a ball that is still painted in the canvas. But how are we going to do that? I'll deal with it later. Okay? So when you push it really bad, yes, top-down design is kind of procrastination, but it is beneficial as well. Okay? It is beneficial as well because see how I can fit the entire drag event handler in one screen map. Okay? If I were to specify the logic, all the logic to check to see if this particular point is inside a painted circle at this time, this would be a lot longer. Okay, like easily three times as long. Okay, so that's the advantage of top-down design, is it allows you to focus on the overall logic, so it's not as easy to get lost in all the details. Now, I don't know about you, I'm not really that particularly good at tracking details, so a few levels, maybe 4 or 5 levels of nesting is the best I can do. Okay, anything after that, it would be kind of difficult for me to track down and debug the code. Okay? Some of you may be able to track down like 7 or 8 levels. I cannot. Okay? But this is something I can track. Okay, look at this code and go, yes, I kind of understand what it's doing. I can see each piece, what it is, how it relates to all the other pieces. It's not a matter of whether I understand what a particular block means. It is a matter of how does it connect to everything else. Okay? All right. So now we have to track down, okay, but how is this procedure done, which is really the important part. So we have the same thing or very similar procedure from last time, and that one is a little bit big. This is initialization. I think I push it all the way to the other side. See this huge block here? That's probably, yep, that's check erase circle. Okay. So let's look at this particular procedure and see, okay, but what is this doing? So we are given the coordinate of a single point on the canvas, and we are asking, okay, please check whether a painted circle is still at this spot, okay, whether I'm over a spot of a painted circle. But I am not using the color to tell me about that anymore. So I have this local variable result already initialized to false. So the default is saying, no, we are not over a painted circle, unless I find evidence otherwise. So inside here, we have a do result block, okay? And the do result block basically is just saying, okay, do something and then give me the answer, okay? So the first block is what we do, and then the last part is what is the answer. The answer is the result variable itself. Okay, so what are we doing? The first thing is, well, assuming that we have to paint over a particular circle, let's just go ahead and change the color, the paint color, to the background color, so that when you paint over a painted circle, it would look like the circle has gone away. Now, yes, we do have that particular issue of the halo effect. Around the edges, we have the halo because it's up to 1 pixel wide because of the smoothing function of painting. Okay, we kind of explained that last time. So we have that paint, that issue, but it's to most people it does not look obvious. So we'll just say, okay, that's fine. It's not a problem.
I haven't noticed it at all online.
It's usually very faint. So unless you really look, you won't notice it. But when your algorithm looks at the color and look for an exact match, it will find it because you only have to be off by 1 in any of the RGB value for your color to be considered different. So unless you build in a margin like plus or minus 10, count is still considered good. So unless you build in that safety margin, then your algorithm will say I'm inside the circle when you're really just over the halo of a circle that is already erased. Okay, but in this case I'm not using the color at all. I'm saying for each item in the list circles. Now for those of you who have forgotten what circles is a list of all the circles. Okay. And each circle, which is an item in the list, is by itself a list. And now it has 4 items in that single circle. We have the xy, which is the coordinate of the center of the circle, the radius of the circle, because in case I want to use circles of different sizes, I want to remember the radius of each circle. And also now we have a 4th item, which is either a 0, which means we have not hit that circle before, or 1 once we have hit that circle. So there are 4 values associated with each circle in circles. So item is basically a list of 4 items, okay, but it's inside another list. Yep.
Did you say the 4th? You have X, Y, the
X, Y, radius, and have we hit this circle before? Yep.
put radius in, so you have different radius sizes.
Right. So I can actually do some fun stuff later on and say, okay, let's change the size of each circle. So inside this particular loop here, okay, for each item, I'm going to do the following. So the first one is this block is just checking, do we even want to go through the rest of the calculation? In other words, has this circle been hit before? If it has been hit before, it is going to have a 1 here. So this comparison will fail, and we're going to skip the entire block and just say, let's move on to the next circle. On the other hand, if the 4th value of a circle is a 0, it indicates that this circle is still painted on screen and we should consider this circle. Okay, am I in this circle right now? Okay, so this block is just saying, am I interested in this circle? If yes, then we'll consider the following, the next one, which is the long equation inequality to say that are we in that circle? Okay, we talked about that before in the previous class, so I'm not going to go over the math again. Okay, it is just tedious. It's just basically saying, is this point xy in this circle or not? Okay, so if it's a yes to this answer to this question, yes, we are interested in this circle, and yes also that we are inside the circle, then we're going to do this part here. The first thing we do is we draw a circle painted over the circle that we are currently over, just to give people the pretense that we have cleared this particular circle. Okay. Now, in a particular game, not in the homework assignment, but in some other game, if you want to paint the circle in a different color, just to indicate this circle has now been traversed, that's fine too. Okay, because I'm no longer using color matching to detect whether I'm on a circle that has not been hit before. So we can paint it over in a different color just to indicate, yes, this is a circle, but we have hit it already. And then we also want to change the last value, the 4th item, from a 0 to a 1, anything other than 0. Okay, but I pick a 1 here just in case I have some other values that will be useful later on. So I'm just changing the 0 to a 1 to indicate, yes, this circle is now hit. It is no longer useful for comparison anymore. But because I have just found a circle like this, I change result to true. Okay? Now, technically speaking, once I find a circle where it turns the result value to true, I can exit the loop already. Okay? But I'm too lazy to do that, so I just let it run through all the other ones before I get out of the loop. Yep.
You replace the list item, you're passing it to item. Item was
A circle.
a circle, so it's
Which consists
a
of
list
the 4 items.
But
So-
it's not, you're not giving it the main list.
You don't need to do it in the main list because when you have a handle, okay, when you have access to one item in a list and it is a list by itself, if you change the sublist, you're always changing the sublist inside the main list.
Is that reference? Is that why?
It is a reference, yeah.
Okay.
So in Java terminology, it is a reference. When you talk about a list, when you have a list of something, it is automatically a reference to that something.
So does that work in Java too? If you have a reference to
I
a
believe
list?
so. If you
Have
use a
reference,
list,
yeah.
that would be the same thing. Yeah. All right. Well, that's the end of this particular loop. And after everything is done, I just say, okay, specify the result of the procedure to be the local variable result here. Now remember, local variable result started off with a default value of false, which means, okay, we're not over any circle unless I find evidence that I am, okay, which is done by this little block over here. So by the time we return, it will indicate whether we hit a circle or not. Now this code would also work if you allow overlapping circles, because it checks all the circles, right? So you can hit 2 circles at the same time if you are in the overlapped portion of 2 circles. Now, but in the homework assignment, I specifically say do not use overlapping circles, so it won't happen. But if it does happen, this will still work.
Except when you rewrite the color of the circle.
It will rewrite both colors. Oh, it will leave an eclipse.
Like a
Yeah, it will.
shape, right?
Yeah, it will leave a little eclipse shape. Yep.
Shape.
Mhm.
Unless you rewrite all the circles each time.
Right. Yep. All right. So, are there any questions about where all the heavy lifting is in this particular case? Now, in this case, when you look at the whole idea of top-down design, this is a little bit bigger. Okay, this is more than what one screen fold can really represent because of 2 reasons. One, it is a little bit bigger by itself, but 2, also because I have a limited resolution, using the projector. Okay, but on a regular screen, it will still easily fit in one single screen. Now, what if you have something that does have blocks like the purple one, like this one, that is just too big to it's just by itself is taking up too much space. You can always collapse it. Okay, in App Inventor, you can collapse a block, which is not the same thing as deleting or disabling. It is simply saying that when it is displayed, it is no longer taking up that much space. Okay, it's just saying that this block is really simple. I know what it does. It's not important in the analysis of the overall algorithm, so let's just hide it. So we just collapse it. But if you want to know what's inside this particular block, you can always just right-click it and say expand, and it comes back. Okay, so this is one way for you to help organize your code and at least help organize how it is displayed, so that when you're working on a particular program or on a particular block that is complex, you can focus on the stuff that is important and kind of just collapse the things that is trivial, so that it's easier to analyze the code. Right? Are there any? Yep. Go ahead.
When you call this, you're passing the center of the X of the ball sprite, right?
Yes.
So then you're only checking the distance of the radius of the current circle to the XY of the center of the ball sprite.
Correct.
That's what you're doing.
Yes. Yep. So the edge of the ball sprite can be touching the circle. I'm not counting that. Now you can change the algorithm to include that as well, okay? Because what you're changing is just how you compare.
Right.
So instead of just comparing to the radius of the painted circle, you have to compare to the sum of the radius of the painted circle and the radius of the ball sprite itself. So if you use that for comparison, then you would you would be able to indicate whether the edge of the ball sprite is touching a painted circle or not. So that would be a fairly easy change. But since the homework assignment specifically asks for the center touching the circle itself, so that's why I'm not using the radius of the ball sprite in this case. That's a good question. Okay. Any other questions related to this app here? Okay. So let's double check, make sure this program is still working. It was working before, but I changed to the center of the whole thing, which also means in order to test whether that part is working or not, a small ball sprite like this is not going to be very helpful because it's hard to tell whether it is the center or not. So let's change the radius to say 20. So this will make it a lot more obvious. Okay, am I checking the center or am I checking the upper left corner of the ball sprite? Okay, so we'll go ahead and build this and start up the virtual machine. And let me just double check to make sure, yep, record is on and it is recording my voice. Okay. So, try S Studio. And just by launching Android Studio, you can understand how virtual machines are important. Because Android Studio itself is a Java program, which means it's using the Java virtual machine to run it. And then in it, we have the launcher of AVD, the Android virtual device. So we are using a virtual machine to launch another virtual machine. SDK. Oh, we're already there. We were there to begin with. Okay, I just backed out of some place that I really should be in. Okay, that's fine. Okay. And I think we got the file already. Yep. So let's save it. Get them all. Go back to this one. Get them all, but APK. There we go. So let's go ahead and check it out. Get them all. G. Get them all. There we go. All right. So I want to start the game. Okay. Click start. The timer is ticking, okay, so I did implement that one as well. So now I want to drag it and see if it is the center that matters when it erases a ball, okay? So it definitely is not the upper left edge, okay? If I push over, okay, you can see how the green circle is not erased, okay? You can try all four edges, okay? Try all four corners. So it is not, oh, okay, I think I actually touched it. Oh, ho, ho. Okay, so we have a problem here. And I think I know exactly what it is. It's because the drag. Okay, I accounted for that already using another chunk of code. Okay, I'll explain where my mistake is. The mistake inside the drag event handler is because I double corrected something. I have something that is already corrected, and then I try to correct it again. See this part here? See the way I move the ball sprite? It's already moving the center of the ball sprite to the point where the pointer is. In other words, current X and current Y is where the center of the ball sprite is, by the way I place the ball sprite. So that's why later on, if I do this, I'm double correcting, I'm over correcting. Okay, so that's why the algorithm is, that's why at this point it's the lower right edge that is actually considering the touching. Yep, go ahead.
If you do it like that, does it cause the ball to jump when you click? If you click somewhere, would it cause the ball to like jump onto your cursor?
Well, let's figure it out. Let's try it out. But first of all, okay, do you want to keep the code like this at this point, or?
Yeah, just see that if you click
Okay.
in the bottom right hand with the ball, drag it if it makes it visible. Like
Well, if it's not a drag, it won't do it.
no, like in the bottom right corner of the ball.
Oh, then here?
Yeah,
That won't drag.
Yeah,
Oh, it will.
Kinda hop
Yeah.
over your cursor a little
Oh
bit.
yeah, it does.
Because you're grabbing it, but then it's trying to center.
Mhm.
Because it's reading on it. Yeah.
It's only when you
Not
drag
really
it.
a big deal, just curious.
Right. Okay, but I can fix this because I overcorrected, so we just need to take this out, get rid of this, take this out, get rid of that. So I was already correct to begin with. Okay, this was correct. Okay, but otherwise the code is working just fine. Okay, it's just using the wrong part of the ball sprite to take out the green one, and this one is going to be funny because it does do that. Okay, because it's also the lower edge. I think the lower edge. Oh, because even though it does not display, my actual touch point is based on the pointer itself. So we're still okay because the actual touch point is here, which means the actual point that I'm using to see whether it's inside the circle or not is here.
For ball sprites, it already uses the center of the sprite rather than the top left. It's just for image sprites that is the top left corner, isn't it? Because when you set the coordinates. Oh no, you tried that. Never mind. You're right.
Yeah, I think we try that. And then the long click works as well. This is the same as the previous problem. And this time, the long click is all it does is to go through the list of all the balls and change the fourth value from 1 back to 0. That's all it does. And then repaint the balls, and that's it. Is that okay? All right. So there are many ways to do this, but each way involves basically a different way of making use of a list, which is kind of the point of the homework assignment, or one of the points of the homework assignment. Okay. So let's get back to the assignment itself, the current homework assignment, okay, which is get them all as quickly as possible. Okay. And it's due on Wednesday, and I did promise that I would release my code so that people who do not have a working program out of the first homework assignment can just use my code as the basis. So I'm going to add it to the homework description itself, so it's easy, it's all at one place. So we'll edit this, go back here, download the AIA file, switch back to the assignment, and put it here. It's called getthemall.aia. So there we go. I gotta remember to click, save the change too, otherwise it won't be available to you guys. Okay, save and return to course. There we go. So now when you click on the new homework assignment, there is an attachment which is the solution of the previous homework assignment. So from there, to make it so that you can keep track of the distance when you are hitting the balls, and keep track of the running sum of that, that should be a fairly minor change once we have the basic program here.
Can we, I got mine adding up the distance, but how can we verify the distance?
Well, okay, to do any type of verification, having everything randomized is not going to help.
Okay.
So you want to basically have a way to generate a particular pattern so that you can actually know ahead of time what the number is supposed to be, then you can cross-check that.
Okay.
The easiest way to do it also is to reduce the number of balls, so just use like 2 or 3, okay, and just place those at known positions.
Okay.
Then then depending on how you traverse, if you have only 2, then it doesn't even matter how you traverse because the distance will still be the same. So I would just do it with only 2, and then just check that you can calculate that value correctly. Because in that case, you know the solution ahead of time. You can just compare, the calculated number, is it the same or very close to the actual number? That's a good question. Yep, go ahead. Yep.
Actually, I think I was distracted.
Oh, okay, I see, no problem. All right. Are there any other questions regarding the homework assignment? Or, yep, go ahead.
If we use the color method of removing the ball, can we continue with ours? Or
Yes, you can.
Okay.
Yep. Yep. Because if as long as your solution is consistent with what I'm asking for, that's fine. The underlying mechanism can be different.
Okay.
Yep. Okay. Any other questions regarding this particular homework assignment? No questions. Now, if I want to make this game a lot more fun by, having different people to work on this, okay, how can I do that? Because now that we can keep track of the distance and the time, okay, we have enough numbers or metric to basically evaluate the solution itself, okay. So we can now have, instead of competing against yourself, you can now compete against other people. So what do we need in order for this game so that you can compete against a friend, okay, who has the same app installed on his or her phone, and you say, okay, let's start, and then and how do we keep track of configurations of the balls? Like, okay, there are specific ones that you can hand design and say, okay, these are tough ones, and it will take, someone, a pretty good mind and quick mind in order to figure out what is the best way to do it. So what do we need in order to make a game, like that? First of all, not randomizing the positions of the balls. Okay, we have actual stored configurations that we say, okay, these are fairly difficult ones or increasing difficulty. So for someone who's just starting out, they can now start to learn how to optimize, this particular game. So what do we need in order to do that? Just have stored coordinates. How would you do it? Okay. We'll definitely need a list, okay? But how do you store this list?
Call to the web and retrieve it if you wanted it, but the data web-based.
Okay.
Through like JSON, like you're showing.
Okay, very good. Okay, so let's just say that we want to be able to store something on the web so that, so that multiple devices can get to the same configuration, okay? How do you accomplish that? Is there a particular mechanism in App Inventor that can do that already? So you don't have to own your own website to do this. Yep, go ahead.
I actually got the custom TinyWebDB database working last night with the Google Cloud, and
Okay.
it wasn't that easy. Apparently, the information that they have on here is a little bit
dated.
out of date.
Yes.
And I had to change the Python version and change a bunch of config settings and stuff. But I got it working, so it
All
is
right.
possible.
Good job. Good job. But there's one thing that is already working that can also be used for this purpose. Yeah. Firebase, very good. Okay, so I want to kind of go through this process, because I want you guys to see, okay, now you get the basic stuff working. How do we make this, improve this game, and how to use extra resources in this particular app? So Firebase is under connectivity or under storage. There we go. Nope, experimental. It is still considered experimental, but it does work. Okay. So when you look at the Firebase DB, we'll just kind of look up the help first. Okay. Oh, this is just the website. More information. There we go. This is the actual help file. So when you use Firebase DB, let's go through some of the methods first. Okay. Now, for those of you who are not familiar with object-oriented programming, which makes sense. Okay, this is a fairly beginning class in terms of programming. When we look at properties, okay, the properties of an object are things that are fairly static, okay, things that are just telling you information about the object. So in this case, certain things you can change and certain things we're not supposed to change, but each one of this is relatively static. It is just a thing that you know about the object. So it's kind of like the height of a person or the gender of a person are properties of a person. So properties are things that are fairly static, usually things that you can change, but occasionally things that you cannot change, you can just read but not write to. Events are specific to event-driven programming, which we're doing. Okay, we know what events are, right? Okay, because with a button, the events are click, long click, get focus, lost focus. In the case of a text box, it really is just lost focus or get focus. But in the case of a Firebase DB, you have these things that are events. Data changed, Firebase error, first removed, got value, and tag list. But the events are not meaningful unless we know what can generate the events. And in the case of a Firebase DB, some of the methods are important. A method of a particular object in object-oriented programming refers to what an object can do. Okay? In other words, properties reflect attributes of an object, but methods reflect what an object can do. So these are typically actions or subroutines or blocks that can actually do something. So in this case, we can append a value. The first one is append value. So we are appending a value to the end of a list. And this is this is guaranteed to be atomic, okay? Which is a term that is not referred to in TinyDB. Now, for the most part, Firebase DB is kind of like TinyDB, except it's web-based, okay? But in the case of TinyDB, how many apps can attempt to update the TinyDB at the same time? Just regular TinyDB, not the web-based.
Just one.
Just one, because you only got that one app, because the TinyDB is specific to a installation of a particular app. Now in Android, you have a limitation. You cannot start an app twice. Okay? If you want to run a browser, okay, on your Android system, you cannot run a browser twice. There's only one single browser. Now you may have multiple tabs, but as far as the number of instances of the apps, there's only up to one. So that means in TinyDB, there's never a problem with oh, but what if two different apps try to update this TinyDB at the same time? Because you can only have up to one instance of an app running, and a TinyDB is private to that particular app. So even though you have your browser, you have your music player, and then you have your App Inventor app running all at the same time, you don't have to worry about any other app being able to change the TinyDB. Okay? In the case of Firebase DB, it's a whole different story, because it is a web-based resource, okay, which basically means every installation of your app running on different devices can attach and try to update Firebase DB all at the same time, quote unquote, all at the same time. Now, if they're all trying to update at the same time, and they're all trying to append something to a list, which is associated with a tag in Firebase DB, then you might end up with a problem of who's actually getting to it. What if you're trying to append a list to the list already? And are we going to end up with a problem? Or we end up with a clobbering problem, okay? Which means the first person will initiate the write operation, get interrupted by a second request to update. The second request is completed. The system went back to the first one and overwrote and overwrite the result already done previously, okay? Or one of the results is lost, okay? So those are the things that need to be considered when you have a web-based resource and using the client-server model, okay? This is using the client-server model when you can have multiple clients and only one single server. So that's why the term atomic is important, because it guarantees that when you have access, when your block gets to execute, it is going to be successful. Okay? While you are updating the resource, nobody else can go in and update it. They can request, they can wait, but they cannot actually do it until you are done. Okay? Is that okay so far? What the term atomic means in this context. Okay. All right. So basically, all it does is to guarantee and say that if you and your app wants to append a particular value to a list associated with a tag, it is guaranteed to be successful and not be interrupted while it is in progress. Get tag list is something that you can also do with a TinyDB. Basically, you just say, okay, give me a list of everything that is in this particular instance of Firebase DB. Can be useful if you just need to know what is in that particular Firebase DB. Get value, hey, something that we have done many, many times. It really is the same thing as get value of a TinyDB, except this time you're getting a value of an item that is web-based. Remove first is kind of the counterpart of append value. This one is adding something to the end of a list. This is removing something as the first item from a list, and it returns that one single item from the beginning of a list. Okay. But these things are new. They're not in TinyDB. Why do you think these are particularly important when we're dealing with Firebase DB? Appending to the end, removing from the beginning. How do we call that stuff? How do we call that thing where when you add items, it is on one end, but when you remove items, it's on the other end? You see that every single day when you go to Costco, when you go to Bel Air, Safeway, go to any supermarket. Huh?
Q.
It's a queue, exactly. It is a Q-U-E-U-E-Q, okay? As opposed to a Q in Star Trek: The Next Generation.
It took me a minute.
Well, only people of a certain age understand what a queue is in that context. Okay, Q in TNG.
John Delancey.
Huh?
Actor.
Oh yeah. So where else? So this is the Q.
My Little Pony Friendship is Magic. In Discord. Who is basically Q, because the fans of My Little Pony Friendship, sorry, the creators of My Little Pony Friendship is Magic were fans of Star Trek: The Next Generation.
I really like this part. Species Q, children Q, partner Q. The Q continuum, actually. Okay, so anyway, we're getting back to the data structure queue, where when you add items, it is on one end of the array. When you remove items, it is on the other end. Okay. So when you go to a supermarket, you go to a line. Okay, we know queue as a line in a more day-to-day basis. Okay, you walk up to a line, you're just adding to the length of a line, and when the counter serves another person, the whole line moves, and then so it's removing items from one end, but inserting items on the other end. Okay, it is also known as what? A queue is also known as it starts with an F. A FIFO, F-I-F-O. Why is it called a FIFO?
First in, first out.
First in, first out. Yep, exactly. So queue, FIFO, line, and they're all basically saying the same thing. Okay. There's also one more term that is really kind of informal, but it really is the same thing. It starts with a B. It's a buffer. Okay, when you're buffering, when you're streaming videos and stuff like that, buffering, that buffer when you're buffering is first in, first out. Okay, so but why is that important when you're dealing with a Firebase DB as opposed to a TinyDB? It makes it easy to have a client-server model. In other words, someone can place request to the end of an item, and somebody can remove those requests, answer those requests, and supply the answer. Okay, let me think of okay, this is great. Okay, so let's think about an app for tutoring. Okay, so you have a tutoring app that is web and cloud connected using Firebase DB. So you have two different types of users, two actors, right? So when you draw the use case diagram, there'll be two magic stick figures. One would represent students, people who ask questions, and the other one would represent tutors, people who answer questions. Is that okay? So you can now imagine that in your Firebase DB, you will have at least one tag associated with questions. And each item off that list is representing several things. the text of the question and who was asking the question. Okay? Is that okay? So your students, or the installation of this particular app on student computers and tablets and phones would use this call, would use this block here to append questions. So each student would say, okay, what is the integration of blah, 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 okay? And send it in as a request. Another student, meanwhile, will ask another question. It's like, okay, what is the proper use of this particular phrasal verb, blah, 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 okay? And another student will ask another question. What about the tutors? The tutors are not adding more questions into this queue, or this line, or this FIFO, or this buffer. The tutors are basically saying, okay, let me see if I can answer that question. And if the tutor can, in fact, answer the question, then the tutor will remove, in that order, the questions that are coming in. Does that make any sense? But it is also helpful to make sure that these operations are also autonomous. In other words, there won't be two tutors trying to answer the same question, and there won't be any dropped questions when people start to insert questions into the question list. Is that making any sense? Is that okay? All right. Not particularly helpful in the case of our application, because we just want to have a game where people can use the same map of dots, okay, to compete. So not particularly useful in that context, but in the case of a tutoring app, it makes a lot of sense. Is that okay so far? What if instead of using FIFO, I use a LIFO instead? What is a LIFO? L-I-F-O. What does it stand for? Last in, first out. Exactly. Okay, so why do you think last in, first out is really bad in the case of tutoring? A tutoring app.
You end up with a bunch of unanswered questions.
Exactly.
The first person waits the longest.
Yep. So people will spam the system because the last question is the first question that will be answered. So people will spam the system by putting in the request as quickly as possible, because if you have the last question into the system, you get the answer first. So you have people spamming the app by clicking the submit question button as quickly as possible.
This is like eBay bidding.
Well, in the case of eBay betting or sniping, sniping, but it's not LIFO because you're not storing anything. It's just that the last one is the effective one. So there's no waiting to clear out the quote-unquote stack. But in the case of a tutoring app, there is one. Okay, if someone doesn't understand the mechanism and submit a question early in the morning when nobody's really around, and then a whole bunch of spammers came online and started to use the system by asking the same question like 20,000 times, then the original question that was asked early in the morning will never get answered. Yep.
How many answers will they get?
Well, and when you clear the answer in the case of a LIFO, then you're reversing the order. So assuming there are tutors online, the whole time, and the overall rate of asking questions is slower than the overall rate of answering questions, somebody will get back to the first question of the day. It will be cleared, but it will be at the end of the day instead of the first question will be answered is the first question that was asked. So LIFO is not really helpful in this case. And in real life, LIFO usually is not very useful because your refrigerator is a LIFO. Think about all the stuff at the back of the refrigerator collecting load right now at this moment.
Oh, you.
Those are the things that you bought a long time ago. Last in, first out.
LIFO is very important for compilers.
Yes, in terms of computer programming languages, formal languages, and the recognition of stuff, the concept of a last in, first out is of extreme importance. But in real life, for the most part, for most people, it is not a useful way of storing and retrieving items. Okay. We have a few other things that are common to TinyDB. Clear tag is just removing everything that we know about this particular tag and take this tag out so the get tag list is not going to show that item anymore. And then we have the usual store value, which is changing the tag completely. Now, this is also important. with store value and get value, it would seem that we can accomplish append value and remove first as well, right? Does that seem to make sense to you? Because to append is really the same thing, quote unquote, the same thing because it's not. It's almost the same thing as getting the list first using the tag, right? Append to the end of that list using a local variable, and then store it later. You can break it up into 3 steps. But the problem with that approach is if you have 2 devices doing that at exactly the same time, you can have clobbering effect. Okay. That is, consider these 2 cases. We are talking about kind of real computer science concept here, okay? But it is important in the case of an application that can be installed on multiple devices and they can all run at the same time using a single web-based resource. So this is still important even though it is more or less an advanced topic. Okay, so we'll have device 1, and device 2, okay? So basically these are 2 different Android devices, 2 different installations, 2 different people using this particular application. Is that good? Okay. So let's say these are 2 students trying to insert a question into the queue of all the questions. Is that okay? All right. So horizontal-wise, we are representing time. So we have this slice of time where device 1 is going to use a get value to get back the list of everything. Is that okay? And then at time slice 2, device 2 is going to use get value to get the current list. So at this time, at the end of time slice 2, both devices will end up with exactly the same value because nobody has changed it in between. Is that okay? So let's say the original queue had 3 questions to begin with. Okay, so now device 1 has gotten a queue of 3 questions. Device 2 also has now a queue of 3 questions. And then at the next time slice, this can happen together at exactly the same time because we are talking about 2 actual physical devices. So this can happen simultaneously. So now both devices say, use the list append block to append a new question. Is that okay? So we grab the 3 questions from the server. We locally append our new question. So device 1 has a question about calculus, device 2 has a question about grammar. Is that okay? So now, both devices now have a list of 4 questions. Is that okay? Okay, now we have the update. So now we have store value from the first device, but because store value is using a web resource, they cannot really happen at the same time. So we have store value of device 1 happening first, and then we have store value of device 2 happening after that. What is the result? What is bad about this approach? Something is lost. What is lost?
The device doesn't have
The question of which device is lost. Device 1 or device 2? Which one has a lost question in this sequence?
probably 2.
Who gets to update last? Device 2 gets to update last, which means this store value is going to override the result of this store value, which also means whatever question device 1 is asking is now lost completely, which is not good. Okay, because that particular student may need to know the answer of that question for an exam on that particular day. Or maybe a student is cheating and asking that question in the middle of that test, right? Okay. So if this is not good, how is append value going to fix this problem? Okay, let's make another time chart here. Okay, so once again we have device 1, device 2. And device 1 and device 2, the end users of the devices, they both click submit question all exactly at the same time. Okay? But only one can get through first. Okay? There's no way that the server can handle 2 requests at exactly the same time. So in this case, we're using append value. But append value is an atomic operation. In other words, the moment the server say, okay, device 1, I'm going to service your request first, it will basically say, I will do everything that I need to do to append the value. And before I'm done with this one, I will not surface another request. Doesn't matter whether it is a get tag list, doesn't matter whether it's a get value, or a remove first, or a clear, or store value. I will not do anything else until this is done. So there's no way for device 2 to interfere and say, oh, I got another question too. Let me override your question with my question. It doesn't happen. Because device 2 cannot do anything until this point. So device 2 will now append its own question after the question of device 1. So that's why we have append value and remove first in the context of a web-based resource. It's not necessary. There's no need to do something like this in the case of TinyDB, but in the case of a web resource, there's a need to do it. But there's another reason why this is useful. Okay? Think of a real app that you're going to do with tutoring. Okay? What do you think would be during the prime time or the peak time of that particular app being used? What do you think would be the number of questions that are basically stored up in the queue? 5, 2, 200, 200,000? Well, if your app is successful, you can be dealing with more than 200,000 questions. Okay? Well, but how are these two blocks going to help? How is append value and remove first going to help? You don't need to get back all 200,000 questions to append just one more question to it. You don't need to get 200,000 questions when you say, I just need the first one. So the amount of traffic going on between the device and the web resource is significantly reduced. Because you're just saying, oh, by the way, add this little tiny thing to the end of this gigantic list. How much bandwidth is that going to use? Not a whole lot. I just need the first one out of these 20,000 questions. How much bandwidth is going to be used? Not a whole lot. As opposed to the other approach where you get the entire list, you get all 200,000 questions in just to add one more to the end, and then guess what? Now you have to retransmit 200,001 question to the server. So even if I have a way to block these 3 operations so they cannot be interleaving with the other operations, it will still not be a very good approach because you're going to be wasting a lot of bandwidth. Is that making any sense? So there are 2 reasons why append value and remove first are important in the case of a web-based resource. Is that okay? All right. Is anyone going to change your final project to a tutoring app? No? Because I think that would actually be a pretty cool app to do too. You can have different categories and in-app purchases. You can have publishers to hook up with you so they can push textbooks and exercise books and whatnot. No, you guys are not interested in making gobs of money.
Yeah, no.
No.
Money is for other people to make.
Well, money is for taxpayers to make. All right. So now that we know what methods we can do, now we go back to events, okay? Because these methods, some of these methods will trigger events, okay? Because events are always triggered by something external to the app itself, okay? Possibly out of the app itself. So the first one is data changed, which is very helpful in many cases. Because data change is an event that is raised when the data in the Firebase has changed. And in this case, it will also tell you which tag has changed and the new value of the tag. So in the context of our tutoring app, okay, this kind of defeats the whole purpose of append and also remove first, because in the context of the tutoring app, if you turn on data change, if you handle data change as an event, and somebody inserted a new question into the Firebase DB, you will get a data change event with a tag of all the questions, and then the value will be the 200,000 questions, which kind of defeats the whole purpose, or one of the purposes of append value and remove first. But in the case of a game, it can be very useful, because now you can actually say, okay, somebody already finished this puzzle, and the time to finish the puzzle is this much. So while you are solving the same puzzle, you can actually see the best result up to that point in time. Firebase error obviously is just an error reporting ability. It can be helpful because you can process this instead of having your app to go haywire. You can basically intercept the error message, and you can display a sensible message instead of having your app crashing. So it's good for error handling. First removed. Now we are talking. Because this one is basically triggered by remove first. In other words, when you trigger a remove first operation, this block continues with the next block almost right away. In other words, remove first as a block is only sending a request. By the time you move on to the next block, there may not be an answer yet. Okay? Is that okay? It returns the first element of the list and atomically remove it. This return is actually wrong, okay, because it doesn't really return the value. It triggers the operation, but the actual value comes back when you handle the event called first removed. It is an asynchronous operation. Time that you send the request and the time that it's done is completely disconnected. Is that okay? So this event, okay, let me just read this part here. First removed as an event is triggered by the remove first function. The argument value is the object that was the first in the list, which is now removed. So by the time you get it, it is already not in the list anymore. So nobody else can get it. You're guaranteed that you are the only instance of the app who's getting that value. Got value is coming back from get value, which is down here. Oops, right here. So this get value is not the same thing as your tinydb get value, which returns right away and say, okay, here's the value that you requested. This one comes back and say, I sent the request to the server, okay? But where's the actual value? I don't have it yet. When it does come back using the network traffic, then it will trigger the got event so that you can use the got event to see which tag did I ask earlier and what is the result of that request. Okay. And tag list is the same thing. It is triggered by get tag list. So get tag list does not give you back a list immediately. It sends a request to get a list of tags, but the actual time that you get the result of the answer is when you handle the event tag list. Are there any questions about this part? Because unlike a tinydb, most of these operations are asynchronous. It means the time that you perform the lock is not when the time the operation is done. Any questions about this? Any questions? All right. So given that we have this kind of mechanism, how do we make the game that we are designing more fun by being able to store puzzles on the server, so that when you don't want a randomized thing and you want to say, okay, I know there are really tough, training, exercises on the server, and I just want to keep doing those. So how would you use this resource for that purpose? Okay, everything starts with a tag, right? So let's go ahead and think about this for a little bit. So you would have a tag. To represent known puzzles. Is that okay? Okay, so we'll call the tag known puzzles. You can call it anything you want, it's just that known puzzles is a kind of descriptive word or descriptive name for this particular tag. But what is going to be represented under this tag?
List.
A list, okay, very good, because since we have the plural here, it already implies that this is going to be a list of some kind, because we are not only storing one single puzzle, we are storing multiple puzzles. Okay, so we know this is going to be a list. What is in this list? What is a item of this particular list? A puzzle, okay. And how do you represent a puzzle?
List.
A puzzle by itself is a list. And haven't we seen that list already? Okay, so you can just use the list that we have already, but you can also give it a name. Okay, so you can have additional attributes associated with a particular puzzle. You can give it a name, like simple, straight line, circle, and stuff like that. Okay, so you can give those things a particular name. All right, so we can have puzzles. Okay, now the game is a little bit more fun because as a designer or the publisher of this game, you can now start to think about, okay, instead of having everything randomized, I can think of tough cases where it is not easy to find the shortest way to get rid of all the dots. Okay? Then you can publish those things, and then people can look through the list of all the puzzles that are stored and pick one and go like, okay, I would like this challenge, I would like this challenge, I would like this challenge. That makes it kind of fun. But it's not as much fun when you can say, I want to beat the high score. Right? How do you maintain a high score in the game like the one in your homework assignment?
You can just use a database again, except this time you send a tag, score, or sorry, you have a tag called high score. You compare the high score on the server to this high score on your mobile device. Either that, or if you want to be more secure, you would do it on the server. But in App Inventor, we're just going to do it in the app. And if your thing is bigger than the highest score, then you go and send your score, or lower, I think, because we're trying to get shortest distance.
If your performance is higher, then you update the high score, and you probably want to be able to enter a name so that your name appears as the name of the high score. So now your app gets a little bit more fun because you can also maintain. Now that is fun, but which high score does it apply to? You got multiple puzzles. Each puzzle can maintain its own high score. So that means when you store a puzzle, it is not really just the list that we're talking about. Now a puzzle becomes a list of key value pairs. Okay, very good. So we have a key value pair for each puzzle, where each item is a key value pair. Okay, so you can have the key being high score, and the value being a particular number in terms of distance or time, or some kind of equation that you work out that represents both time and distance. And you can also have another one to say who is the high score, who has the high score, which is a string, okay, that gets displayed while you play that particular puzzle. It will say so and so solved this particular puzzle in this much time as you are trying to solve it under pressure. Okay? And then the third one is the actual puzzle itself. So you can have puzzle as the key, and then the value is going to be the list of circles that we are using earlier. So you can make this, complicated, a little bit more complicated like this, by attaching additional attributes to a particular puzzle. So in addition to just the circles, the coordinates and stuff like that, you can now include high score, who has the high score, and when the high score was set, and so on. Go ahead.
You want a name on there too?
Name of?
Puzzle.
Oh yeah, the name of the puzzle. Okay,
And
so
then
you can have
you
a
don't
name.
need to track in the puzzle, you don't need to track the true, false, or whether it's on the screen, that can be tracked.
That's correct.
Locally, right? So you
Right.
have a subset of the list
Right.
to save if you want to save that.
Yep. But you can also track when the high score was set. Okay, that can be fun because nobody has broken this high score for the past 5 years. I'll give it a crack.
High score for the year.
Yep. Or when the puzzle was created, okay? Because you might want to say, okay, are there any new stuff today? What are the puzzles created for the past week? Okay. So you can store additional attributes for each puzzle, so they can have those other things that you can also do with these puzzles. Any questions about this? No questions? Okay. So while you're playing the game, and somebody else is playing it, and then the other person just got a high score, okay? So now the question is, while you're still halfway through the game, do you want the app to flash and go like, somebody just beat this particular puzzle with a new high score while you're halfway through the game?
No, because it'll like distract them.
But some gamers may want that. They want to be competitive, right? They want to go like, okay, I'm doing this with 20 of my friends, and it's a new puzzle. We are all starting at the same time, so they want to know how each other is doing, right? So you can use the method or use the event called data changed. Yep, go ahead.
Make it an
Yeah,
option.
Yes, you can make it an option.
Because because I know that there are people who might not want that, and so like the safest option is always make everything optional,
Yep.
and then nobody will complain.
Unless you default it one way or another. Some people would say.
Get something out.
Yep. Did you have an earlier question?
No, you answered it.
Oh,
Data
okay.
change. I was wondering
Yeah,
how
data
you're gonna
changed.
post it to the game.
Yeah, data change is going to do it. But data change is also going to report, every single thing that has changed. So every time you add a new puzzle to the puzzles, it will trigger a data change. Now, it may be good because, when somebody is not in game, then you can just pop up a screen and say, oh, a new game has been uploaded. Okay, do you want to give it a try?
But you can filter those once they arrive based on what the user's doing, right?
Oh, yeah, you can
So
do-
only report on this game. Or
Yep,
something.
yep. You can also you can have multiple screens on this app. So when you're in the game screen, you just ignore the other events. Because you can have one screen that is the overall screen that allows you to navigate to, okay, I'm going to play a game now, I want to look at my history of playing these games and so on and so forth. So in that screen, maybe it's okay to intercept data changed and say, oh, by the way, somebody just uploaded a new puzzle, do you want to give it a try? But you can switch to another screen to actually play the game and have no data change event handler in that screen to actually do anything. In fact, that other screen may not even hook up to Firebase DB at all. Because by the time you get to that screen, you only need to know the local puzzle, right? Which can be passed using the start value. So that screen for just playing the game with the canvas does not need connectivity to Firebase at all. Very good. How would you upload a new puzzle? Because if we are tracking all these known puzzles, somebody has to upload these, right? So instead of having to have a separate interface on the PC to design the puzzles and upload it, what would you do? You can have a particular screen of this app here to let you, hand design a particular puzzle.
Yeah, and if you're feeling particularly adventurous, once you have that, since you're have it for internal use anyways, you might, depending on how you feel, you might want to go and give it out to the user so that users can create their own levels. Of
Yep.
course, that thing kind of, that'll depend on your marketing, because sometimes you don't want users to create your puzzles because you want to make sure every single puzzle is really high quality. So sometimes, like if the users create it, it might not necessarily be that high quality.
Okay, I know
But,
I think we're skirting feature creep here. But if you want your game to be like that, where some people can contribute new puzzles, but you don't want to pre-approve every single puzzle, then you can use these methods here. You can maintain a queue of incoming new puzzles, okay? And another one that actually is all the approved puzzles. So the incoming can basically be evaluated. Okay, those are the ones to be evaluated. So when a puzzle is evaluated by at least 200 unique people, and the score is high enough, then you can automatically incorporate it into the actual known puzzles. But if enough people say, no, this is not good, then you just toss it away. So now the question is, how can you get some puzzle to be evaluated 200 times? When this method when you can only get append the last one and remove the first one. In other words, there's no way here to say peak, okay, and change in place. Okay, there's no such call. How do you do it? When you need something, a mechanism to evaluate something 200 times by 200 different people.
Probably another list of
You don't need that. You need a counter, okay? You need a counter per item to be evaluated. So what you do is when something is getting evaluated, you remove it. So that only one person can evaluate it at a time. When that person is done evaluating, then your algorithm will say, okay, is this the 200th evaluation? If so, apply the criteria. Should we add it to the known puzzles or not? What if this is like a third evaluation? What do? Throw it back using a append value, but with the counter incremented from 3 to 4. So now you have this queue of incoming puzzles to be evaluated, and they keep going around and around in the queue until it has gone through 200 evaluations. Then either it's tossed, lost, okay, or it's added to known puzzles. Yep.
Is the counter added to the puzzle data?
Sorry?
Is the counter added to the puzzle data?
Yes.
Okay.
Yeah, it will be added to
Each puzzle has its own counter.
Correct. So each puzzle, while it is being evaluated, will have its own counter of how many times it has been evaluated. But the key idea is you have to remove it first, evaluate it, and then put it back into the list. And these things are useful because now only one person can be evaluating at a time, guaranteed. Yep.
What happens if they turn off the machine in the middle of it? It doesn't get pushed back.
Hmm?
They turn off their phone or whatever. And the
And then- but by the time you do the remove first, it's going to be gone. So the problem cannot be done with a timeout, because if you turn off the phone between remove first and append value, that's when bad things happen. Yep.
So can you do both at the end, right? Oh no, because you don't want somebody else to get the same game while somebody's playing it.
So, okay, to solve that problem, okay, now we're kind of pushing the envelope of this app a little bit further, but it's a realistic problem, okay? It's a realistic problem. What if somebody is halfway evaluating and then battery runs out, the whole phone died, right? Okay, so when that happens, so the only way to kind of avoid that problem is when you are to maintain that queue of things being evaluated, the way you do is you do not attach the puzzle itself to that queue. You apply a particular tag or little stub representing the puzzle. So when something is checked out using remove first and not returned using append value within a certain amount of time, you basically say, okay, I think it is lost, okay, or something bad has happened. So then you regenerate the token back into the pool with the last known value. So now you go back and say, okay, it was evaluated 3 times, but the 4th time after you checked out, it was never returned within a certain amount of time. So you regenerate that token back to it has only been evaluated 3 times, put it back into the pool.
But the problem is that this is the database in the phone that is doing all the work. It's turned off, so you need middleware somewhere in there to evaluate that, right? Or you need someone else's phone to do it.
That is correct. You need some third mechanism to do it. Yep.
That is what middleware really is, right? It's that
You can
logic between front-end user and database.
You can cloud it too, okay? Because you can look at everything that has been checked out. So every phone, every instance can be a monitor of the overall system. So now you're not delegating to a single management unit to do all the managing. Basically, every single instance is helping to manage it. Yep. But you can see how things can get complicated as you start to consider all the things that can happen. All right, we got 2 minutes left. I just want to kind of tell you one more thing in real life that is related to apps, and I think it's a really kind of interesting thing. My son lost his flute last week.
Lost his flute?
Flute, yes. Yeah, he left it in the music room, but when he went back, he couldn't find it. Okay, so that's kind of expensive. So, what type of app can be useful here?
Find my flute.
Okay, so I got 2 examples. I got 2 things that I want you guys to know about with apps. So this is the first one, tile. Okay, the tile app can be useful because the tile app, I hit a tile in his case, like behind all that, the casing material, between the casing material and the actual case, I hit a tile, T-I-L-E. And so, at least I will be able to track the last known location of his flute. I didn't install the tile app on his phone. I probably should do that so that his phone can be used to at least have a digital leash on the tile. Okay, so that's one application. I think the tile app can make an alarm when a tile is no longer in contact with your phone. So I think that would be helpful as well. So that's the first app. The second app that I found was really useful was I talked to my car mechanic over the weekend. And he went to an Apex show, which is basically, they talk about all the new technology and whatnot. And one company made an application or a device, I don't know exactly whether it's a device itself or whether it's an app that you can run on any phone. But basically, by placing the phone running that app on the dashboard or someplace, okay, in your car, in your vehicle, it can analyze the sounds, the noises coming out of your car, and pinpoint and say your left tire is underinflated, or you have a shaft problem somewhere in the engine, or your transmission needs fluid change and whatnot. So it's using all kinds of signal processing to locate problems with cars. And according to whoever was making that particular app, the accuracy is pretty high. So I just want to let you know of what people are doing with mobile apps and all kinds of applications where 20 years ago we would never even imagine. Okay?
Good for used car shopping.
It's good for used car shopping. It's also good for long trips, because if your tire is underinflated, and it's one of the things they can detect, it can tell you ahead of time before it fails. And according to my mechanic, it can even tell which tire is having a problem, which I think is like, wow, that is really, really cool. So it might be a different device, it's not just your phone, because it might need multiple pickup to have a direction of where that sound is coming from. But signal processing and the algorithms for signal processing is getting to the point where people can do something like that. And that to me is impressive. All right, so we are getting out of this class, going to the lab. And for those of you who have not finished your homework assignment, now you have my code as a basis, so you can now start to work on the homework assignment, which shouldn't take long.